good morning, everyone. So I'll present our work. This work was actually published last year in the International Conference of Natural Language Generation, and it's a joint work with Jonathan Herzig that actually led the work, Tommy Sandbank and David Konopnicki. Just to mention, this work won the best short paper award. You can see there Jonathan receiving the award. Okay, so conversational agents or automated bots, whatever you call it, they are all around us. We see them in robot IoT settings, mobile apps, and also customer service. And if we look on previous researchers, then we see that it's well known that an automated agent can actually benefit when adapting its personality according to some task. It can be according to an application, a brand, or even a culture. So one example is a research that we did last year in which we found that when there is a match between the personality of, in a setting of customer care, between the personality of the customer and the agent, if there is some kind of match, then the prediction of the satisfaction is higher at the end of the service. Okay, so what are personality traits? We are not psychologists, but just in few words. So basically, it's a kind of set of traits that try to define some durable characteristic of a person. It has models starting from the 1960s and become robust around the 1980s. And there are many models. We are using one of them, which is the most common and popular one. It's called the Big Five, or Ocean. And it has 5 traits: openness, conscientiousness, extraversion, agreeableness, and neuroticism. Specifically for our work, which, if you remember, the title was about customer service, we are focusing on 2 traits: the agreeableness and conscientiousness. Those traits are already known to be very important in customer-agent interaction. So what is agreeableness? It's the person's tendency to be compassionate and cooperative towards someone else. And conscientiousness is the person's tendency to act in an organized or thoughtful way. So let's just keep those in mind. Okay, so what we are trying to do in this work, we want to basically find how we can encode the personality traits as part of a neural response. So you see there an example. Those are the 5 traits that we have. And our idea is basically to be able to decide how much trait or how much weight we want to give to each one of the traits in order to generate some response based on some targets. And our approach is using architecture of sequence to sequence. Okay, so here are 2 examples. Those are real examples from our data. In the first example, we have the customer asking, why isn't your service working? And then we have 2 types of answers. The first one, we call it a consensus agent. Basically, a consensus agent is an agent that has no idea of personality traits. So this is the sequence-to-sequence generation. And the answer, you can see it all. It's we are aware of the issue and are working to fix it. The other answer that we have, we call it from agreeableness agent. This agent has a high trait of agreeableness. And now when you read the response, which is basically the same semantic, you see that we are happy to help. Are you getting any error or codes? The first part, we are here to help. It shows some empathy, some compassion. And the other one, asking questions, it shows the cooperativeness of the agent. The other example show an agent with a different trait of the conscientiousness. And again, you guys messed up with my delivery today. The consensus agent responds with, please contact us if you don't get it by the end of the day. And the one that has high trait of conscientiousness, please email etc., we will check on it. There is some more thoughtful way to handle this utterance. Okay, just to mention, there are two related work. First one is an early one from 2007, led by Walker. Basically, we argue the same thing that they argue, that personality traits will have some linguistic cue. And in their approach, they look on a rule-based approach. So basically, they study and learn how, what a linguistic cue appears, and then they just came up with rules. For example, they found that high conscientiousness, usually they used longer words or more informal one. The other, which is very also relevant to us, is about persona-based neural response. The main difference between this and our work is that they have some kind of abstract persona. So you can maybe think of it like a persona to vec. So they basically using IMDb data. They are generating characters from TV series, and for based on the conversation and the text, each actor or each character is getting an abstract persona. And I will go back to this one. Okay. So I mentioned that we are building on top of sequence-to-sequence architecture. So we are using LSTM encoder and attention-based LSTM decoder. So this is the baseline. And our model is, as you can see here, adding actually two new inputs that we didn't see earlier. So there is a new hidden layer. This one, the HP, which is basically, and there is another layer of vectors. So those are vectors. So for each agent, we're extracting some vector to represent the personality. And this is the vector of P, and I'll show later how we do this. And basically, our model is learning during training time these weights of how to map a vector of traits that we can explicitly define into later an output. So this is our model. Okay, so basically we used a data set of 1 million conversation over 62 customer service from Twitter channels. First, we have to do some filtering, and we remove agents. They had less than 30 utterances, customer agent utterances, and I'll mention why we did this. And we ended up in around 80,000 utterances. Okay, so I mentioned personality traits. This is not. We didn't do it by ourselves. We used a service of IBM that called Personality Insights, which basically get someone text, and the more text it gets, the higher quality of the personality it can predict. And this is why we removed those that didn't have enough evidences in our data. So we collected, and we had a very high quality and reliable personality trait for the agent. And then when we give the text, the output of the service is actually a vector of a length of 52, which looking on the big 5, it's the one that I mentioned earlier, size of 35. There are some other personality by needs and values. So this is the input vector that we have. Okay, so now we experimented with two different settings. The first one, we call it a warm start. And the idea in warm start, I think this is the regular setting in which we see all the agent that are in our training data, and then we do and dev and test as usual. We compare ourselves to two models, the regular sequence to sequence and the one that I mentioned about the abstract persona. And we're looking on measure of perplexity and BLEU. So the lower perplexity, the higher quality, and vice versa for the BLEU score. So you can easily see that our is our model is the last one. And you can see is that it's much better than the sequence-to-sequence. It's a little bit worse than persona, but maybe equivalent. But if you look on the BLEU score, you see that our result is actually lower than the one of the persona. And this is not that surprising. So you need to recall that in our setting, we are limited only to the setting of personality traits, where in the abstract persona, they can capture actually other things that we are ignoring or neglecting at that point. For example, it can capture the city that you live or some other aspect of the person itself that we don't capture because we are very limited and focusing on the personality traits. And then we did another experiment, which we call the cold start. Here, the data is a little bit different. So the idea here is that we want to train only on, in our case, 90% of the agents, and then we want to do the testing on the 10% of agents that we never saw. So you can imagine, and maybe go back to the motivation, let's assume that I have a customer and I want now to generate the perfect matching of agent for this customer. In our model, we can actually set what will be the weight or what will be the importance of each one of the features as much as I want. And this is why first we cannot compare it to the persona-based, because in the persona, they must see and know the persona. They cannot come with a new persona, whereas in our case, you can now generate really new personas. And then again, if you look on the sequence to sequence, then we are outperforming in both quality. So I think from this one, we take out that adding personality is really good. Now, as you have mentioned, we also did some human evaluation because BLEU and perplexity is not enough. In this case, what we did, we showed judges, actually each triplets of customer and 2 agent got evaluated by 5 judges. We generate 2 agents. The first agent, we call it an agent with a high trait. So we set all the vector to be 0.5 in all the features. Only one feature, in this case, for example, agreeableness, we got high trait score, 0.9. And agent 2, we did the same, 0.5 for all the feature, but in agreeableness, we gave it very low, 0.1. And then, and you see an example, we gave those triplets to the crowd and asked them whether the first agent is more or less agreeableness than the response is more agreeableness than the other agent. Eventually, we got that 61% they agree with the output of the model, which is somewhat more or more. So people actually saw the personality within the response generation. So just to conclude, we show how we can add and use personality in a neural setting into the encoder. We look on the setting of customer service. We showed some improvement in the quality and also by human judges. Oh, so the question was whether personality changed over the time. No, so I mentioned in the personality is a very durable, catching a durable characteristic of a person. So we assume that it takes a very long time, like years, for a person to change his personality. So once we have a person, it will have one personality model. Okay, so the question was about when we match between customers, on the previous research that we did, when we match between customer and agent personality, how we can measure that the satisfaction is higher. So we actually did it, there is a whole research about it, but we measured the people feedback on this task, and we saw improvement, higher satisfaction when there was a match between them. I can point you to the paper.
Thanks so much.